You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Philip Plait, aka the Bad Astronomer. Philip Plait is an astronomer and skeptic who runs the website badastronomy.com. His book of the same name was released in 2002. In 2008, he became president of the James Randi Educational Foundation. He received his PhD in astronomy from the University of Virginia in 1994. With a thesis on supernova SN 1987A. Remember to subscribe to Event Horizon so you never miss an episode.
Phil Plait, the Bad Astronomer, welcome to the program.
Thank you. It's nice to be on.
Now, Phil, I've read your blog for years, and you definitely resonate with me as far as rational thought and critical thinking, which is how I try very hard to live my life. But you've mentioned before that there was a time where you hadn't quite arrived there. What was young Phil Plait like?
How young do you want to go? When I was a little kid, let's say 10-ish and early teens, I was not skeptical about things. And let me be careful here and say that I loved science. I loved reading about science. I loved talking about science. I watched science shows on TV when they were on. Big fan of PBS and all those shows. But when it came to thinking critically about claims that were made about things, I didn't necessarily dig into that and think about them in a way that made me say, could this be right? Could this be wrong? You know, what's going on? What's the evidence? And so I wound up believing in a lot of stuff, even up to young high school. I really wanted to believe in UFOs and paranormal stuff, ghosts and ESP and all that kind of stuff. And it wasn't until I was a Midland teenager, I guess, that I started thinking, these claims aren't really holding water too well, and went the other way. And it's not that, a lot of people knee-jerk. They believe in one thing, they see it's wrong, and then they go completely the opposite direction. It's not like that when you kind of find critical thinking. You wind up applying this to everything and saying, I think that this claim about UFOs is wrong. Let's look at it. I think this claim about this galaxy might be wrong. Let's look at it. You apply it to everything. So it wasn't just like I rejected the paranormal. It's more like I looked at it, thought about it, and analyzed it and said, yeah, no.
Yeah, I sort of did the same thing when I realized that I wasn't seeing any of that stuff. And I was like, I just don't see any indication that that's, the case. And then as you get older, you realize that reality is reality, and then there are some things that just simply aren't. And then maybe there are things that we just can't quantify. Who knows? But I still keep an open mind, but again, no compelling evidence so far. With the possible exception of perhaps some of the UAP stuff, do you think that, having once been interested in UFOs and looking at the case now, do you think that's changed a little bit and that there might be a little bit more there than what we had originally thought?
No, not really. just to be pretty perfunctory about it. I've seen these videos, and some of them are very clearly mundane phenomena. Another airplane, balloons, birds, Venus, the usual stuff. Some of them are harder to explain, but a lot of people want to make the jump to unexplainable or explainable through, I don't want to say supernatural, and I'll talk about that word in a minute, but just going sort of outside the parameters of science and saying, yeah, these must be alien spaceships. And the problem with that is that you can't eliminate all the mundane stuff. It's very difficult to do that. Some of these videos are weird. There are effects, there are camera effects going on. There are perspective effects going on. There are issues with distance and resolution and all these different things that make it extremely difficult to analyze. Like, for example, just yesterday, a friend of mine sent me a message saying their kid saw these lights in the sky. And what could this be? And I looked at the video, and it's like, well, they're in a V formation. So the first thing you think is birds. But they're awfully bright, like they're shiny. And I thought, so maybe they're drones. And then he got back to me and said, And I told him at the time, I said, with this video, there's not really any way to tell. And he got back to me a few minutes later and said, from a different part of the park, they got a different angle on that sighting. And you could see they were birds. They were definitely dark objects. They were dots in the sky. But while you couldn't see the wings flapping or anything, it's pretty clear they were birds. The fact that they looked shiny and white from one angle really was a red herring, so to speak. So it's very difficult to interpret these things. And at some point, you can eliminate some of these videos and say, yeah, this is an airplane, this is a balloon, whatever. And you'll have some pile of them left over that you haven't explained yet. And then I say, the burden of proof on me isn't to show that these things cannot be aliens or whatever. The burden of proof is on you to show that they're not mundane. And at some point, these videos, you just can't tell. There's not enough information in them. They may be interesting, but they're not really presentable as evidence, in my opinion.
And I have to say, too, that one thing that I wonder about regarding the phenomenon, and again, I have an open mind, I'll look at the evidence or whatever, the videos, but one thing that bothers me is I have seen Earth's atmosphere do some very strange things in the course of my life. For example, a fata morgana, a mirage of buildings. And I was probably 30, 40 miles off the coast of Florida, and there I was seeing floating buildings in the air. So there are things that this atmosphere can do that you might not expect and you might not see every day that could be misinterpreted if you didn't know what they were.
That's correct. And in fact, I want to be careful. I'm not saying that these videos are not alien spaceships or whatever you want to interdimensional whatevers. I'm not saying that's not what's happening. What I am saying is that you really have to look at all the mundane stuff first. And at some point, you sort of run out of evidence and you have to make some leap. I'm not saying that, well, let me phrase it this way. If you want to claim that these things are alien spacecraft, you have to do better than these videos. There's just not enough evidence there. And there very well could be aliens out there visiting us. I have not seen compelling evidence for it. On the flip side of that, a lot of people who want to argue with me about this don't spend any time looking up at the sky. And I think I'm talking to these people and I realize they don't maybe understand that, yeah, satellites at night can get very bright. They can reflect sunlight and get a glint where you just kind of see this little faint dot moving across the sky slowly. And then it gets suddenly very bright and then fades again. And if you're not aware of that happening, or you're not aware of how meteors look, or what kind of cloud formations there are, or this list goes on and on and on. If you're not that familiar with the sky, then you can't come at me with some claim about flying saucers. I hate to use that phrase. I don't mean to diminish this, but the point is, you kind of have to have that experience before you can tell me that I'm wrong, saying that this is probably something mundane.
And that's the key, because again, Earth's atmosphere does some strange stuff, ball lightning, plasmas, all sorts of things that you just don't see every day. And if you didn't know what that was, then you're sort of left to speculating.
Right.
One of the weird things, though, that I've noticed about the UAP phenomenon, and again, I'll echo what you're saying. I'm open. I'll look at anything, but it doesn't look all that alien to me. You wouldn't expect an alien civilization to very wastefully fly around and defying the laws of physics and things like that. It just doesn't quite make sense. So to me, it doesn't look like any of the above. I don't know what it is, but I can't again leap to aliens, especially in the light that they don't really look like aliens. Do you agree with that?
Sure. Up to a point. And I understand what you're saying, and I'm always willing to say, listen, it's difficult enough for two cultures that are quite different to understand the other culture, even when they share the same country, same state, same county, same town. It can be difficult to bridge that gap. And if you're talking about aliens who they're alien, I think that's the phrase. The thing about aliens is they're alien. That's an old science fiction aphorism, and it's. You don't necessarily know how they think, what their situation is on their planet. We are very driven by certain forces of nature on this planet with evolution and the evolutionary pressures. The pressures on their planet could be completely different. The chemistry could be completely different. And so over 1 billion years, intelligent life could be so different than us that there's no way that we can understand why they do things. We don't understand their psychology. And if they figure out some way of having spaceships that go faster than light, then right away, we're dealing with a technology that we don't understand, that goes against the very basics of physics as we understand it. And so, if they send spaceships here that hover and slice up cows and probe people or whatever, I can't just dismiss that as silly because they think differently than we do, maybe. On the other hand, that's not the direction I really want to go with this sort. I want to look at the evidence itself and say, is this compelling evidence that we're talking about an extraterrestrial craft? And that is what I have never seen. And people say, well, then what will satisfy you? And I'm like, there's a cliche, landing on the White House lawn. And honestly, that's it. If you can show me a piece of a spacecraft that is so far advanced of us that there's no way a human civilization could have made it, or a bona fide alien walking up to me and saying nanu nanu, then yeah, I'm there. But up until that point, the evidence just isn't that good.
Even if you had that, the alien landing on the proverbial White House lawn, there's a problem there. And that the closer the alien is to you, the more difficult it is to prove it's actually an alien and not something from your planet that you were unaware of. And this gets into, I believe Jason Wright wrote a paper on this, that maybe prior technological civilizations on Earth or something like that. So whenever you have a close alien, it gets harder to prove that it's actually an alien, right?
I guess. I mean, I'm certainly not expecting him to look much like us. Seth Shostak, who is an astronomer with SETI, the Search for Extraterrestrial Intelligence, has written about this a little bit, saying, in a sense, humans are fairly well designed in that we are tall so that we can get above obstacles like grass and shrubs and we can see far away. Our vision is decent. Our sense organs, the eyes, ears, mouth, and nose, are clustered around our brain so that the impulse travel time from our ear to our brain is very short. So there's lots of things. Bilateral symmetry is kind of a natural way of things evolving on land. So when you look at a human being, you say, yeah, this isn't a bad construction. And so you might expect aliens will also be symmetric and have a central processing unit, a brain with the sense organs around them and everything. But, they won't look human. And, if you go into the ocean and say, if you accept that blue whales or dolphins, cetaceans, or maybe even octopi and other cephalopods, that they're intelligent, maybe not like we are, but they interact with their environment, they can reason things out, and they don't look anything like us. Now, they may not be driven to explore space, so, they may not be the kinds of aliens that we might see coming to visit us, but in my opinion, there may be certain universal constructions, body types for intelligent aliens. There may not be. And this is where we run up against the very basic problem, is that we basically have an example of one, and that's us. And until, or at least our lineage, going back to Neanderthal and so on. So it's very, very hard to extrapolate what aliens would look like if the conditions on a planet were just even a little bit different. We just don't know.
Now, envisioning alien environments like this is the subject of your upcoming book. Can you tell us about that?
That was a really good segue. I'm impressed. That was well done.
Yes. That's why they pay me the little bucks.
That's right, exactly. And then I don't have to make some sort of ham-fisted, I've written a book about this. But no, you're right. I've written a book. It's called Under Alien Skies, A Sightseer's Guide to the Universe is the subtitle. And it's not about aliens. It is about alien environments. I wanted to answer a question I get all the time when I write, back in the day when I was writing more about Hubble pieces, and now, we're writing about JWST images. I get a question is this what it would really look like if you were there? Here's this image of Mars. Here is a gas cloud in space. Here's a galaxy. Would these objects look like that if you were there? And it turns out that's not always easy to answer. There are two different ways of going. And one is to say, well, no, telescopes and cameras operate in a different way than your eyes do. So even going to Saturn, which is a solid object that has colors and structure, if you go there, it's not going to look quite like it does through a telescope because just the way those images are taken is not the way your eyes work. But also, a lot of the times, the objects themselves are inherently different. there are gas clouds you can look at through a telescope that look very bright, but that's because you're seeing them small through the eyepiece, right? There's you see a bunch of stars and there's this little gas cloud that looks like a donut, say. But if you were inside that gas cloud, it's what we call a nebula. If you were inside that nebula, you might not even know you were in it, because that gas is now spread out all across the sky. And so you're taking all that light that you've concentrated into basically a little dot through the eyepiece and then spread it out over the entire sky, which is huge. And it gets so dim that without scientific instruments, you might not even know you're inside a gas cloud. The sky will look black at night. You'll look at objects through a telescope, they'll look just like they do from Earth. So it depends. And what I wanted to do was tackle this idea in the book and say, I've seen the movies where they go up to planets and they get the scale wrong, they get the colors wrong. They show Saturn's rings up close and it's not quite right. And let's take all of our current understanding of what Saturn looks like, what we know about Mars, what we know about gas clouds and planets around other stars, different kinds of stars than the sun. Put ourselves there and say, I'm going to look up in the sky, I'm going to look at the landscape around me. What do I see? And more than that, it's like, what do I see over time? What are the seasons like on this planet? Can you see other planets? This is a thing in Star Trek too. When I was a kid, I'd watch Star Trek, and they'd land on this planet, and you see the sky, and there's like this gigantic moon, like 3 other moons next to it. And I'm like, is that even possible? And it turns out the answer is, kinda, yeah. And I wanted to do the math, think this stuff through, and then write about it as if you were there, and describe it like you are standing here, this is what you see, and then pull back and say, here's why. And that's what I've done in this book, to make a short story long.
I have to point out something. I have experienced this, and I think many of us have, in the form of the great 2017 solar eclipse. Visually speaking, with human eyes, that eclipse was absolutely jaw-droppingly magnificent, and no photograph out of thousands of eclipse photographs I've seen, none of them did justice for what it actually looks like.
That's correct. That was my first solar eclipse. Or I should say my first total solar eclipse. I've seen plenty of partial eclipses, lots of lunar eclipses, but never a total solar eclipse for myself. I've seen thousands of photos, lots of videos, including incredibly well-done images that show the sun's corona, its outer atmosphere, the structure in it, and the photos of the Earth during an eclipse, which is weird, eerie, twilight. And I've read the stories that birds will stop chirping and crickets will start cricketing, making their noise, and it's a visceral experience, and you cannot know what that's like until you are there. You can imagine it, but it was an amazing thing, especially the fact that it takes an hour for things to really get started. As the moon starts covering the sun, it doesn't get that dark. You don't notice a big difference until right before the eclipse, but the character of the light changes because the sun is a big disk in the sky. It's the same size as the full moon visually. They're both about half a degree across. So if you think about how big the full moon looks in the sky, the sun's about the same size. And that spreads the light out a little bit. It makes the edges of shadows a little fuzzy. If you go outside and stick a stick in the ground and look at its shadow, the edge isn't that sharp. It's not like if you take a flashlight or a distant light, shine it, and you get a sharp shadow. The shadow's a little blurry. But as the moon starts to block the sun, you're starting to get the light from the sun in a smaller and smaller slice. And it changes the shadows. It changes the way the light looks. It's really hard to describe. And when you're there, you feel it. Everybody was looking at each other like, this is weird. What is it? And I realized it's because the timbre, the tenor of the light's changing. And then the experience of totality, which is incredibly emotional and beautiful and awe-inspiring. And you kind of have to be there. And it's a problem I ran into with the book. It's without standing on the moon, how do I describe what it's like to be in lower gravity? How do I describe that even walking is difficult? And so I decided to do a trick I did in my last book, Death from the Skies, where I actually wrote a short vignette. Basically, some of them are first person, some of them are sort of third person, but it's describing sort of you're walking on the moon, you see this thing, and these things happen. And then in the next section, I describe the science of why that's happening. It's sort of the best I could do to put somebody in that situation, like the old TV show, You Are There, where they would reenact historical events in the first person. That's what I tried to do.
Now,
Not that anybody remembers that show. You'd be turned to dust if you watched that show on TV at this point.
I did, but I'm basically turned to dust, admittedly.
Yeah, I know, me too. I remember it vaguely, but that's about it.
Yeah.
It's like 50 years ago.
Yeah. Well, I'm getting close to 50, so.
Oh, you whippersnapper.
I remember. Yeah, I remember at least 42 years ago, something like that. Now, what was the most wild environment that you came up with, that really mind-blowing and unearthly, as it were?
That's a good question. You know what's funny is I just announced this book a week ago as we are recording this, and I've been writing it for 2 years, and it's been fairly all-consuming. I had to do a lot of research. Oh my God, I had so many papers I read, so much math I had to do just to describe how bright is the sun when you're standing on Pluto, and that's not too hard. But some of these other calculations were a little more involved, and so right now at this point in the book's evolution, this is my very first interview about it, just so as you know. And I haven't really thought about what kind of questions are people going to ask me. And I should have thought, they're going to ask me, what's the weirdest thing? What's the coolest thing? And I should have thought of this in advance. So that's my preface to this. You know, when you're writing about something like a black hole, that's pretty much always going to win for weird. These things are distorting space and time. And I've already written about black holes so many times for the blog and articles and my previous book, talking about it on TV and all that kind of stuff, TV documentaries. And I wanted to do something a little different. And so, yeah, I do talk about falling into a black hole and how weird that is and what happens. But there are other weird effects where if you're even far away from a black hole, it's bending space. And light follows that bend in space in a similar way that a car will follow a bend in a road. And if the curve is really tight, that road will be super elevated, right? It'll tip a little bit towards the center of the curve so that you don't go flying off the road. And so a car following the bending of a road is very similar to light following the bending of space in a black hole. And so you get really bizarre optical effects. Stars will appear to move in different directions. If they're directly behind a black hole, you'll see a ring, like a halo around the black hole. That's the star's light being bent in every direction around the black hole as you're looking at it. These are very difficult concepts to describe, and so it was hard. But I think, black holes, they get a pass. They're just starting with black holes is so strange that they're always going to win when you're talking about stuff like that. But what I found to be really interesting to write about from a personal standpoint was the moon, I would have to say. I mean, Saturn, yeah, and seasons on a planet that orbits two stars. That was kind of cool to have to figure all that out. But just writing about the moon, because the moon seems familiar. It's up there in the sky. We see it all the time. We're sending probes there. We've got pictures of close-up pictures of it. And in the end, we've sent a dozen people there who went to the moon during the Apollo era and came back. And yet, there are still some things that were unfamiliar to me as I was reading about it, and things I had to think about that turned out the sort of standard things that people say about what it would be like to stand on the moon aren't necessarily 100% correct. And it was kind of fun to go through that and figure it out and write about it.
Do you foresee a permanent human presence on the moon anytime soon? Or do you think that maybe Artemis and all this might be another flash in the pan? What's your view on the future of the exploration of the moon?
Those are kind of two different questions. Do I see a human presence on the moon? I shouldn't say absolutely. There are always possibilities that funding dries up or a single rocket blows up on the pad and then that's that. And we've seen that happen in the past. So, you never say absolutely. If the trajectory of space exploration continues on the path it is now, let's put it that way, with some wiggle room, then I would say yes. Looking not so much at the Space Launch System and Artemis. I am not a huge fan of anybody who's been reading anything I've been writing for the past few years would already know that. I just feel that SLS is not the right rocket for NASA to be building. It was a huge mistake, but get back to that in a second. However, China, European Space Agency, SpaceX, and Blue Origin, Jeff Bezos's company, they're looking to build rockets that can go to the moon and bring people to the moon. And looking at SpaceX, I wouldn't bet against them at this point. I may have some issues with the CEO of SpaceX right now. I think a lot of people do, but the company itself has made huge strides, just ridiculous strides towards putting people in space. Just the idea of a reusable rocket, nobody would have thought that was possible 20 years ago. It was science fiction. And now you see the Falcon 9 first stage land on a floating platform in the Atlantic. This is absolutely pure 1950s black and white movie science fiction stuff. And we're looking at those videos and going, yeah, seen it. I mean, it's happening all the time now. And this gigantic Starship rocket that SpaceX is building, that very well could work. And the way they're designing these things and testing them, I wouldn't bet against them. So yeah, it could very well be that. I don't want to put a time on it, but we will be putting people back in the moon in the next couple of years if things go the way they are. 2020, by the end of 2025, 50-50 maybe. 2026, yeah, sure. And they'll be going there for a little while and coming back. But looking at the plans and the way things are going, I wouldn't be shocked if in 10 years we start to have a permanent human presence on the moon in a similar way that we have a permanent human presence in space on the International Space Station, in that you have a small crew that goes there, stays for a few months, another crew comes, they overlap for a while, then the first crew comes home. So there's always somebody up there. I mean, the space station has been continuously occupied for 20 years, I think. It's something like that. It's been many, many, many years. There's always been somebody in space. And that could very well happen with the moon.
Now, what are your views on Mars? Is that further out and not as likely?
Mars is... People want to lump the moon and Mars together. Like, if we can go to the moon, we can go to Mars. And it's like, no, that's a different kettle of fish. It's like saying, if I can bike to the store, I can bike to England from the United States. Like, no, it's a different problem, and you have to define it differently. Going to the moon is not easy, but it's only 3 days away by the kind of rockets that we build now. The Apollo missions took roughly 3 days to get there. You can bring enough supplies to live on the moon for a week or two with a Saturn V type rocket, and then come home again. So you can basically do this in one shot if you only want to get to the moon, look around, go, hey, look at that, that's cool, pick up some rocks and come home. Just doing that for Mars is entirely different, because it takes 6 months at best, 5 months at best, and 9 months depending on where Mars and Earth are in their orbits. So it could take anywhere from half a year to a year, very roughly. Now you're talking about bringing 6 months worth of supplies with you, and oh wait, that only gets you to Mars. You got to be there, do stuff, and come back. So you need to bring a huge amount of supplies. People need something like a ton of consumables per year. It's some number like that. So you can imagine how much you have to bring with you. It's a huge amount. And so right away, you can't bring that much with you unless you have a monster rocket like Starship. And even then, it's not easy. Your better bet is to send an advanced uncrewed rocket there first with supplies, land it, and then have them waiting for you when you get there. And the trip, it's 6 months of microgravity. You don't weigh really anything. There are issues with that. Your bones deteriorate. Your body makes adaptations to that makes it very hard to come back to Earth, or even to walk around on Mars. Your eyesight changes, and you have to, that's why we have the space station. We're testing all this. So it's very, very difficult to do that. And there are threats of radiation. A solar storm could send lethal radiation through your rocket, and so you have to deal with that, and that's not that easy. So it's a completely different problem, and I suspect it's not. Despite what NASA and ESA and SpaceX says, I think it's going to be quite some time before we send people to Mars. I will be happy to be wrong. If we can send people to Mars and get them back safely sooner than I think, and I'm talking 20 or 30 years, great. But I think it's going to be a lot longer than most people think.
Now, let me ask you this. Would you go?
Oh, absolutely not.
I agree.
How do you like that? After spending 10 minutes on all these explanations, you ask me a question like that, and I'm like, oh no, no.
I agree. I am not going to space at all.
Yeah.
Zero interest. Even though I'm intensely interested in space and have been my entire life, I'm not going there.
How come you don't want to go?
Well, number one, danger. Number two, the food can't be that good. I like my hamburgers and things like that down here on Earth, and I don't think we'll see orbital McDonald's anytime soon. And then plus, astronauts also point out that food tastes differently in orbit.
Mm-hmm.
So I just like my human creature comforts and walks on a nice day and things like that. That there are no nice days on Mars, so I'll stay here.
No, Mars is like designed to kill people. It's a really, really hard environment to get to. This is an explanation that we had to talk about a lot when the bigger landers started going there, like Spirit and Opportunity and Perseverance and Curiosity, that it's got an atmosphere. It's not enough of an atmosphere to really slow you very well using drag, like the Apollo astronauts did coming back to Earth. They just basically slowed themselves down like a meteor does using drag and then parachutes. The problem is there's not enough atmosphere to really slow you that way, but too much atmosphere to ignore. So it's this boundary region where it's like, well, we can slow ourselves a little bit, but we need really big parachutes to be able to do this right. And it's just really, really hard to do that. But yeah, I agree with you. I mean, it's there are creature comforts. Plus, for me, I know that I get sick on a playground swing if I'm not careful. Reading in a car is enough to lay me out. And ironically, on a boat, I tend to do really well. Other people are getting sick, and I'm fine. But I just know that if I strap myself into a rocket and go into space, I'm going to spend that whole time puking, just sick out of my mind, and I'll hate it. So, and just the idea of going into a rocket is terrifying. I have no desire to do that.
Yeah, I have the same problem, motion sickness, and weirdly enough, boats don't bother me, but automobiles do. So I don't know. Where can everybody find your newsletter?
Yeah, I have a newsletter that is called Bad Astronomy, the Bad Astronomy newsletter, and I publish it on Substack, which is the popular newsletter platform. So it's badastronomy.substack.com. At the moment, I publish 3 a week. There's one on Monday that's free. You just get it you sign up, you get it in your email inbox, and 2 more, one on Tuesday and one on Thursday, and those are for paid subscribers. And I write about the news, things that interest me. There's some, opinions, recipes. I mean, it's a newsletter. You got to have a recipe in there every now and again. But whatever sort of tickles my fancy. And it's a lot of fun to write. And it's kind of taking the place of the articles I used to write on the various platforms that used to host me, like Discover Magazine and Slate and Sci-Fi Wire. Now I'm independent, and it's a lot of fun to be able to just sort of write whatever I want and cover issues as I see fit. And that includes things like, well, we were talking about skepticism earlier and unidentified aerial phenomena. I can write about that, and climate change, vaccines, anything I want to write about. And that's what I do.
Speaking of skepticism, to get back onto that subject, there has been a huge increase in comments lately regarding the sun going micronova.
Oh, really?
Yeah, it's been huge. It's making the rounds on the internet, and I just wanted to put it out there. What actually is a real micronova?
There's not really any such thing as a micronova. Not really. The term, the word nova, which actually means new, it comes from the Latin stella nova, stellum nova. I can't remember the exact Latin phrase. It means new star. Back in the day before telescopes, on occasion, astronomers would see a star pop into existence in the sky, and they called it a nova. Astronomers would look in the sky, and a new star would pop into existence, and they would call it a nova. And what this turns out to be, they didn't know then, but we know now, is a particular kind of stellar system that undergoes periodic explosions, and they get very bright. These are huge explosions that put out a million times the energy of the sun for a short period of time. So it gets very bright and then fades away. And then we discovered another class called a supernova, which is when a star completely explodes. And it turns out there are different kinds of those. And then very recently, there was something called a kilonova. And it turns out it's about 1,000 times more powerful than a nova. So we call it a kilonova, kilo meaning 1,000. And that's, again, a separate phenomenon. Now, what this conspiracy, I don't know if I call it a conspiracy theory, but what this pseudo-scientific idea is that the sun undergoes periodic explosions, and they call them micronovas. And I wrote about this because there was some guy out there talking about this on YouTube or whatever, and I'd have to go back and read about it to remember all the details. But he's describing, well, let me put it this way. What he's describing is nonsense. He's saying that every some number of thousands of years apart, the sun has this huge explosion and it could threaten life on Earth and blah, blah, blah. And it turns out this is just all based on garbage. It's not science at all. The sun does have explosive events on its surface, solar flares, and much larger ones called coronal mass ejections. These are intense. They are very local. They're confined to a single spot on the sun. And let me tell you, a lot of energy. And the sun is capable of flinging a lot of energy our way, and it's done it in the past, and it will do it in the future. But the way these folks describe it, it's just not possible. And the cycle of these things, they say it's 20,423 years apart or something like that, whatever the number is. And it's like, no, you can't really know that. You're just kind of sort of making that up. And this is very, very common with this sort of astronomical doomsday mongering that these folks do. Anytime astronomers discover a new asteroid that gets within 10 million kilometers of the Earth, and these people are saying, it's going to hit us. No. The Mayans were saying doomsday in 2012. No. The sun is going to, no. And that's been my job for a long time, is to basically go, no, that's not how this stuff works. There's enough real stuff out there that's cool and enough real stuff out there that's dangerous. Let's look at this stuff realistically and scientifically and not do this sort of breathless fear-mongering just for clicks. And that stuff, it really makes me angry.
About asteroids, which do present a risk, but not for very much longer, apparently. Were you surprised by the results of the DART mission?
Ooh, surprised. That's a good word. Some of it surprised me. The fact that we could hit an asteroid with a space mission didn't surprise me because we've done it before. In 2005, NASA sent a probe called Deep Impact, which they say is a coincidence because it came out after the movie, but the initial design of this probe was before the movie came out. And it's called Deep Impact, and it hit a comet called Tempel 1. And it actually, the spacecraft itself didn't hit the comet, but it released a gigantic block of copper, of all things, to slam into this comet and carve a crater in it. And the idea wasn't to move the comet. The idea was to excavate a lot of the material to try to see what the inside of the comet looked like and what it was made of. So the fact is they did that once before. DART, however, is using, and DART stands for the Double Asteroid Redirect Test. I always have to think about that. Double Asteroid Redirect Test. It's a double asteroid. It's an asteroid called Didymos, and it has a small moon called Dimorphos. And so it's a double asteroid, and this mission was to hit the moon, and impact it hard enough to change its orbit. So it hit Dimorphos and changed the length of time it takes to orbit Didymos. And they were hoping to change it's about an 11-hour orbit. They were hoping to change it by about 10 minutes. It uses very new technology to autonomously aim itself. And it was a very relatively simple spacecraft. It was kind of like a camera and an engine, pretty much. A little bit more than that, but that's essentially what it was. So it used the camera to look at the asteroid and target it and make sure that it was aimed the right way, and slammed into it. And what surprised me was how rapidly this thing was able to send back images. It took one image a second. And this asteroid's relatively close to the Earth. It's 11 million kilometers away at the time of impact, 7 million miles. And that means that it was close enough, the spacecraft was close enough to Earth to be able to send us this imagery relatively quickly. The bandwidth was good. So it's sitting there taking these images every second. And you're watching live as this asteroid's getting bigger and bigger in the camera. Then we saw, when it got close enough, and things were really rocking. It was, we were seconds to impact. We could see that both of these asteroids looked like rubble piles. When I was a kid, we thought that all these asteroids were gigantic monolithic blocks of rock or metal or whatever. And it turns out they're not. They're actually more like bags of rubble held together by gravity. They're not solid at all. They're made up of millions and millions and millions of smaller rocks and boulders. And now we're seeing that, in fact, probably most small, if not all small asteroids, and small meaning a few hundred meters across, they're all like this. And so as Dimorphos got bigger and bigger, and I'm looking at it going, oh yeah, absolutely, that's a rubble pile. And then it hit. And the really surprising thing was how much debris was ejected. I don't think anybody was thinking that we would be getting a huge plume, tens of thousands of kilometers long from this thing. And it turns out that's good, because what we're trying to do is say, if there's an asteroid headed for Earth, we want to push it out of the way. And if we slam it with something, it's kind of like a defensive lineman hitting a quarterback. I may have my football analogy wrong. I'm not a huge sports fan. But, the defensive team hitting the quarterback and knocking him into the out of bounds, for example. You're trying to change that path of the asteroid so that it doesn't hit the Earth. So you whack it really hard with a spacecraft. And first of all, it worked. I mean, they hit the asteroid. But the fact of the matter is, it also ejected this huge amount of material, and that acts a little bit, or in a very similar way, to rocket exhaust. By flinging this material out, that also pushed on the asteroid, gave it a second kick. And this idea has been around for a long time, but nobody really knew how much of an extra kick it would be. And now these measurements of the asteroid's orbit has shown that it did not change by 10 minutes, it changed by 32 minutes. They got 3 times what they were hoping for out of this thing. And I have to think, and I haven't heard the science yet. I imagine there'll be a lot of papers published about this, but I have to think it's the fact that it ejected all this material out the back end that gave that extra kick to that asteroid and moved it more than they were expecting. And I think that's the big surprise. Again, to make a short story long, but there's a lot of surprises here, but I think that's going to be the big one.
Do you think that there's a possibility that some volatiles might have been vaporized and that might have pushed it a little bit?
Oh, I hadn't really thought of that. It is possible. And by volatiles, you mean things like ice, things that boil at a low temperature, for example.
Yep.
It could be, because I have to think about this. I'm thinking about this out loud, so be careful. I want to be careful here and say I could be totally wrong. The spacecraft was moving very rapidly, over 6 kilometers a second, and it weighed 500 kilograms, something like that. I may be getting my numbers wrong. But it basically slammed into this thing hard enough that the energy equivalent was like setting off a ton or more of TNT. So it's a fairly energetic event. And if there were things in there, like ice, that could flash vaporize them into a gas. That gas would expand very rapidly and push on the asteroid as well. I don't know how much of an extra kick that would be above just simply flinging stuff out the back, which is Newton's first law? Every action has an equal and opposite reaction. So if you take a rock and throw it one direction, you're going to be pushed in the other direction. And that's what was pushing on this asteroid. Also, you may be exposing ices that were inside that asteroid, and then sunlight could hit them and warm them up, and that would give you an extra kick, a small one, and more of an extended one over time. But all of this stuff, I'm waving my hands, all of this stuff is good together because that gives you extra force. And the idea here is you're trying to push on this thing as hard as you can to change its path. And you don't have to change it much, because the key to this whole thing is finding an asteroid headed towards us early. The more time you have to push it out of the way, the more likely it is you can do that. Let's say you change the motion, the velocity of an asteroid by 1 centimeter per second. That's very, very slow. It would be hard to walk that slowly, right? So in 1 second, it's now moving, it's now in a 1 centimeter different position than it was. Well, in 100 seconds, it's now a meter different. And in 100,000 seconds, which is a little over a week, now it's moved a kilometer. Now the Earth is, and I'm sorry I use metric, it's the way I think now. I can use English units and say the Earth is 4,000 miles wide. If you can spot this asteroid and change its velocity enough that by the time it gets to where the Earth is, it's now been moved 4,000 miles, you're going to miss the Earth. That's the whole key here. You want enough time so that even a slow change in velocity means it's going to miss you. It's similar to crossing the street. You look to your left and you see a car that's really far away. Well, you have plenty of time, so you can just mosey across the street. However, if it's really close you have to run across the street. Your velocity that you have to move gets a lot greater the less time you have before that car is going to hit you. So the more you can change the velocity, the better. But what's even better is the longer the baseline you do. So we really want to find these things really, 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 really long in advance, 10, 15, 20 years, and say, yep, that one's headed for us. Whack it with a spacecraft, and then hopefully that's enough to change it. If not, you hit it again, or you use other methods to move it. But that's what we're trying to do here.
Do you foresee that the advent of the Vera Rubin Observatory and the LSST will greatly expand our knowledge of these potentially dangerous asteroids?
Absolutely. And I said you can't say absolutely, but here I am saying absolutely. Asteroids are hard to find because they are far away and faint, and the sky is very, very big. Telescopes tend to look at very, very small sections of the sky. I mean, if you took like a cocktail straw, that teeny tiny little hole in it, and hold it up to your eye, that's sort of the field of view of a telescope. The very famous Hubble deep fields, which show all those thousands of galaxies, the amount of sky that is covered by those images is equivalent to holding a grain of sand on the tip of your finger at arm's length. That's how much sky those things cover. So telescopes tend not to look at big areas of sky. And the ones that we're finding, the asteroids that we're finding right now, are due to telescopes that have a wider field of view. But these telescopes tend to be small. You want a big telescope because you can see fainter objects with a bigger telescope, but bigger telescopes tend to have a narrower field of view. Now, though, we are able to make bigger telescopes that have wider fields of view, and this is the breakthrough that we've needed. And the telescopes you mentioned, like the Vera Rubin telescope, which what used to be called LSST, the Large Synoptic Survey Telescope, and there are other ones, Pan-STARRS, and there are a few other ones out there. These are big telescopes, as they can see really, really faint objects. And the key is they can see really big areas of the sky. And so, if you're looking for a needle in a haystack, it helps if you can look at a lot of haystack all at the same time. And that's what these things are doing. So they can literally take images of the entire sky over the course of one night, 2 nights, 3 nights, something like that. And then, you can only see so much of the sky because there's daylight, but over the course of the year, they're going to see the same areas of the sky over and over and over again. And that makes it a lot easier to look for moving objects like asteroids. And so we're talking about seeing far more asteroids, orders of magnitude more than we do right now. And that means we can see them farther in advance. And now that we have this technology with DART, I'm not saying we can push a dangerous asteroid out of the way because Dimorphos is quite small. And bigger asteroids are harder to push out of the way. But I am saying that the pieces are falling into place to secure our future against asteroid impact.
And many other things. That telescope and that method of observation is going to yield information on interstellar objects, Kuiper Belt objects, and possibly even Planet 9. And that's my last question for you today, Phil, is do you think that has legs?
Well, the guy, Mike Brown, the astronomer who is a part of Konstantin Batygin is his partner, that their scientific partner, they do all this stuff together, and they're the ones who proposed this idea of Planet 9. Mike's an old friend of mine, so I'm not going to say, no, he's full of crap, he's wrong. On the other hand, I can't say he's right. There is a lot of evidence that there is a large planet, a major planet, maybe not quite as massive as Neptune, but probably more massive than the Earth, what we call a super Earth, orbiting the sun, very, very far out past Neptune. The evidence comes in the form of these objects that orbit the sun, these icy bodies that are like comets that orbit the sun out past Neptune. And their orbits should kind of be randomly oriented. Just they can be tipped left or right or up or down, or just they can be pointed any which way. And the more of these things we find, the more that we find that the orbits are kind of lined up together in a way that doesn't make sense if it were random. However, it does make sense if there's a giant planet out there that is, through its gravity, affecting the orbits of these objects and lining them up. The evidence is really interesting, and a lot of people have tried to prove this wrong because that's how science works. And they say they could be aligned because of the way we're observing them, or because of this or that, and it turns out it's hard to show that these alignments are due to anything except for a planet out there. The only problem is we haven't found it. It's faint. It's really far out there, and it's never been seen. So that's one of the things Mike is doing with other astronomers, is scanning the sky looking for them. And with the advent of the Vera Rubin telescope, which goes online very soon, these other telescopes, it's entirely possible that they can either find it or rule it out. They can see so faint and so far away that they can say, there's no planet out there bigger than Earth out to this distance. And that would mean that that's just not enough planet to affect these comets this way. There must be something else going on. So either, they're going to support it or they're not going to support it. But we may know within the next few years if there's another major planet in our solar system that we have missed for all these centuries. That would be super exciting.
All right, Phil, we are out of time. Where can everybody pre-order your new book, and when does it come out?
Thank you for asking. It comes out on April 18th, 2023. It is available for pre-order now. You can just go to your online bookseller, whatever you like, and look for my name, Phil Plait, or Under Alien Skies, and pre-order it there. And you can also find me on Twitter as Bad Astronomer, and my newsletter is badastronomy.substack.com.
All right, Phil, I hope you'll come back and visit us sometime, and I wish you great luck with the book.
Thank you very much. I appreciate it. Thanks for having me on.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.
John, have you seen my context chip?
No, what makes you think I have it?
Have what, John?
The context chip.
Oh, yes. I don't know where that is.
Well, I saw you-know-who in here yesterday. The possum might know where it is.
I would hope so. He'd get lost a lot otherwise.
Wait a minute. No, the chip, not the possum.
Speaking of chips, John, have you seen my context chip?